A three-wheeled tractor that could pivot inside a dock aisle barely 10 feet wide. A French hauler so massive it ran tires at less than 1 atmosphere just to stay on top of Saharan sand. A 2-story rolling stage that turned any parking lot into a science exhibition. These are some of the oddest trucks the 1950s ever produced, and every one of them solved a problem nothing else could. They weren't design failures. They were engineering answers to questions most people never thought to ask. So what made those questions so urgent? On the docks of post-war Britain, space was measured in inches, not feet. Horse-drawn wagons had once ruled these narrow quays, weaving between rail sidings, cranes, and warehouses. But as cities swelled and goods moved faster, the old ways could not keep up. Enter the Scamel Scarab, a machine that looked more like a cartoon than a truck. With its 3 wheels and rounded snub nose, it seemed almost playful, but every curve and angle was a direct answer to the chaos of the docks. The Scarab's single front wheel could rotate a full 360 degrees, letting the entire tractor spin on its own axis. That meant it could turn around inside a dock aisle barely 10 feet wide, an impossible feat for any 4-wheeled lorry. The forward control cab perched the driver right over the wheel, shrinking the vehicle's footprint and giving a clear view of every obstacle. Underneath, the mid-mounted engine sat low between the axles, dropping the center of gravity and making the Scarab steady on uneven cobbles or when darting between stacked crates. But the real revolution was hidden in plain sight: the automatic trailer coupling. With a pull of a lever, the Scarab could lock onto a trailer, haul it to a loading bay, then drop it and pick up another, all in the time it took a horse team to be unhitched. One Scarab and a handful of trailers could do the work of several rigid trucks, shuttling loads from ship to warehouse without ever blocking the narrow lanes. In a world where dock aisles were often less than 10 feet across, and where every minute of loading time cost money, this odd little tractor was a marvel of efficiency. Restorers today marvel at the Scarab's practicality. Its engine could be removed by 2 men in under an hour, and the pressed steel chassis shrugged off years of hard use. What looked unconventional was, in fact, a direct response to the tight geometry and relentless pace of Britain's industrial heart. The Scarab did not just replace the horse, it redefined what a city truck could do, proving that sometimes the strangest solution is the smartest one. For more stories of hidden engineering genius and the machines that shaped our world, consider subscribing. There is a lot more to uncover. Across the Atlantic, American cities were growing fast, and their streets were filling with delivery trucks. But there was a catch. By law, most states cap the total length of trucks and their trailers at 40 feet. Every extra inch spent on the cab meant less room for cargo. This single regulation pushed designers to rethink the entire layout of the urban delivery van. The answer came in the form of the cab-over, or cab-over engine, design. Companies like REO and International Harvester led the charge. Instead of a long hood stretching out front, the cab was perched directly above the engine and front axle. This wasn't about style, it was about squeezing every cubic foot of space into the legal envelope. A metro van, for example, could offer nearly 16 feet of cargo area inside a vehicle barely 25 feet long. That meant more milk, bread, or groceries delivered per trip, all while staying within the law. Shorter wheelbases gave these vans a huge advantage on crowded city streets. Tight alleys and sharp corners that would stump a conventional truck became routine. Drivers could swing a metro van through a busy market, back it into a narrow loading dock, or make a 3-point turn in a cramped alley. Municipal codes in cities like Chicago and New York even specified minimum turning radii for delivery vehicles, pushing manufacturers to refine steering geometry and axle placement. The cab of her van's boxy shape and stubby nose might have looked odd compared to sleek passenger cars of the era, but every line and angle was dictated by the need to maximize payload and maneuverability. In the world of urban delivery, efficiency wasn't just a selling point, it was survival. These vans prove that when laws and logistics collide, the result can be a machine that looks strange but works brilliantly. The lesson was clear. Practical needs, not convention, drive the boldest innovations. Nothing on the road or off it looked quite like the GMC Future Liner. Towering at over 26 feet when fully deployed, with a gleaming red and white body shaped like a cross between a bus, a spaceship, and a locomotive, it was built to turn heads. But this was not just styling for the sake of spectacle. In the mid-1950s, General Motors needed a vehicle that could haul its entire parade of progress across the country, transforming from highway hauler to mobile stage in minutes. The Future Liner was their answer. A rolling theater, exhibition hall, and billboard all wrapped into one machine that could squeeze under highway length limits while still unfolding into a platform big enough for a crowd of 3,000. Engineering was unlike anything faced by city vans or dock tractors. Instead of maximizing cargo, the Future Liner had to maximize attention and accessibility. Its coachwork was a puzzle of folding panels, hydraulic lifts, and hidden compartments. With the push of a button, side doors swung open and a stage platform slid out, powered by onboard generators. Floodlights and public address systems fired up from inside, turning any parking lot into a full-blown showground in under half an hour. The height, an incredible 26.5 feet at full extension, was not just for show. It let the Future Liner rise above crowds and obstacles, making its displays visible from blocks away. Inside, space was so tight that every inch had a purpose. The cab, perched high above the front wheels, seated a driver and 2 crew, with the engine tucked behind and below. The main body carried exhibits, lighting, and the gear needed for rapid setup, all packed with the precision of a ship's hold. Even the tires and suspension were chosen to handle the weight of steel panels and stage machinery, not just highway miles. On tour, the Future Liner's convoy covered over 20,000 miles a year, stopping in more than 100 cities and drawing millions of visitors. It was a showpiece of mobility, proving that even the oddest packaging could make perfect sense when the mission demanded spectacle, speed, and self-sufficiency. In a decade obsessed with efficiency and progress, the Future Liner showed that sometimes the most practical solution is also the boldest. The lesson carried forward. When engineers put function first, the results might look strange, but they work, and sometimes they dazzle. In the late 1950s, a convoy crawled across the Algerian Sahara, each truck looming like a moving mountain above the dunes. At the heart of this procession was the Berliet T100, the largest truck in the world at the time, and arguably the strangest. Its scale alone defied belief, nearly 50 feet long, 16 feet wide, and weighing over 100 tons fully loaded. But every inch of its bulk was a direct response to the desert logic. The Sahara offered no roads, only shifting sand and heat that could melt asphalt. Standard trucks would sink within minutes, their narrow tires digging hopelessly into the dunes. The T100's answer was a set of 6 Michelin tires, each more than 7 feet tall and nearly a ton apiece. Inflated to just 0.7 bar, about 10 pounds per square inch, these giants spread the truck's weight over a vast footprint. The result was ground pressure lower than a human foot, letting the T100 float atop the sand where others bogged down. Convoy logs from oil field expeditions record these trucks crossing drifts that swallowed bulldozers, hauling loads of up to 100 tons at a steady crawl. Power came from a 29.6-liter V12 diesel, an engine more at home in a locomotive than a truck. With 700 horsepower and immense low-end torque, it could drag a loaded rig up grades of 40%, slopes that would stop most vehicles cold. The semi-automatic transmission paired with multiple reduction gears allowed inch-by-inch progress through soft ground, while an auxiliary diesel ran the steering and cooling systems to prevent breakdowns in 50-degree heat. Even the chassis was designed for the desert. A reinforced steel frame resisted twisting on uneven ground, protecting both cargo and crew. The cab, perched high above the tires, gave drivers a clear view of the terrain ahead, a necessity when a single misstep could mean a day of digging out. The Berliet T100 was not a product of excess or showmanship. It was a tool built for a singular purpose: to haul oil field equipment across a landscape that defeated every conventional truck. In the expedition logs, there is a sense of awe, drivers describing the T100 as a land ship that made the impossible routine. Here, the oddest shape was the only rational solution. The desert demanded something extraordinary, and Berliet delivered, proving once again that when engineers put function first, the results may look bizarre, but they work. On the battered roads of post-war Czechoslovakia, the Tatra 111 handled terrain that would cripple most trucks. Its secret was hidden beneath the cab, a massive steel backbone tube running the length of the chassis. This was not just a structural oddity, it was an answer to a world without reliable roads, where bridges were scarce and detours could mean days of slogging through mud, snow, or rutted tracks. The backbone carried the full weight of the vehicle and its cargo, channeling stress through a single rigid path. That meant the frame did not twist or crack, even under a 14-ton load bouncing over broken ground. But the real magic happened at each wheel. Instead of rigid axles, the Tatra 111 used swinging half axles, independent arms that let every tire move up or down by nearly a foot. As the truck crawled over rocks or through deep ruts, each wheel stayed pressed to the earth, keeping traction where other designs would lift a tire and lose grip. The geometry allowed camber to shift dynamically, so tires always met the ground flat, spreading the load and preventing rollovers on steep side slopes. Czech Army tests in the late 1940s clocked Tatra convoys completing 99% of rough terrain crossings, while conventional rivals bogged down or snapped frames. Power came from an air-cooled V10 with 12.2 liters of displacement, mounted right over the front axle. Air cooling meant no radiators to puncture or freeze in winter, and the engine delivered over 200 horsepower with a mountain of torque at low revs, enough to keep the wheels churning through axle-deep mud. If something did break, the modular design meant crews could unbolt a section of the backbone, swap out an axle or drive shaft, and get rolling again in hours, not days. The Tatra 111's form looked strange, but every detail served a purpose. It was a machine built for survival on the worst roads in Europe and beyond, its backbone and swinging axles quietly rewriting the rules of heavy transport. Where others saw an oddball, engineers saw a blueprint for reliability, a lesson that would echo in off-road trucks for decades. Moving a 100-ton Centurion tank across post-war Britain demanded more than horsepower. British military engineers in the 1950s faced a logistical riddle: how to transport massive armor over roads never built for such weight, across bridges that could fail under the strain. Their answer was the Thornycroft Antar, a machine designed for relentless, controlled force, not speed. At its heart, the Antar carried an 18-liter V8 diesel engine, originally intended for locomotives, tuned to deliver over 800 pound-feet of torque at low revs. This was not about racing down highways. It was about getting a fully loaded transporter moving from a standstill, inch by inch if necessary, even up muddy inclines or through bomb-damaged towns. British axle load limits capped each axle at 18 tons, so the Antar's 6 driven wheels spread the weight, each axle carefully balanced to avoid crushing the roads beneath. The ballast tractor configuration, anchored by a steel slab behind the cab, pressed the rear tires down, maximizing grip without overloading fragile bridges. The drawbar was no afterthought. Instead of a rigid link, the Antar used a modular, pivoting drawbar, letting the trailer track behind through sharp bends and uneven ground. This allowed 100-ton payloads to snake through narrow lanes and tight depots, places where a conventional truck would be useless. Laden convoys rarely topped 27 miles per hour, but that slow crawl was intentional. Steady movement kept the load distributed, the cargo safe, and the roads intact. Procurement files from the Ministry of Supply read like a checklist: maximum payload, minimum axle weight, modular drawbar, low cab, absolute reliability. The Antar's ungainly profile, long, low, cab-over engine, with a ballast box behind, was pure function. It hauled tanks, pipelines, even bridge spans, earning its name, the mighty Antar. Its legacy endures in every heavy-haul tractor built for what works, not what looks right. Out west, the Kenworth Bullnose greeted mechanics and drivers with a face that split opinions, rounded, bulbous, and unmistakable. But behind that distinctive snout was a quiet negotiation between style and service. In the 1950s, American trucking was booming, and every minute a rig spent in the shop was money lost on the road. The Bullnose's signature curved hood was not a stylistic flourish. It was a direct answer to the daily grind of maintenance. Unlike flat-fronted cabovers that forced mechanics to wrestle with cramped panels or remove the entire cab to reach the engine, the Bullnose's rounded bonnet swung open wide, giving easy access to the radiator and all the vital parts up front. Kenworth's dealer catalog even boasted that a radiator could be pulled in under half an hour, a small miracle for highway haulers running coast to coast. This design was not just about keeping trucks moving, it was about listening to the men who fixed them. Regional operators in logging, mining, and long-haul freight all had their own demands. Some wanted the short bumper-to-back of cab length for tight turns on mountain switchbacks, while others needed quick service on desert runs where breakdowns meant hours stranded. The Bullnose became a compromise, short enough for city docks, tough enough for rough roads, and, thanks to that rounded hood, friendly to the wrench turners who kept America's freight moving. Decades later, the Bullnose stands as proof that practical needs can shape even the oddest forms. When function takes the lead, what seems strange at first glance often makes perfect sense in the hands of those who rely on it. In the world of 1950s trucks, the line between oddity and genius was drawn right across the service bay floor. Every oddball truck of the 1950s, no matter how bizarre it looked, was built around a handful of principles that still echo in the world of heavy vehicles. First, visibility and packaging. When engineers pushed the cab forward, perched drivers above engines, or tucked powertrains under the floor, they were not chasing style. They were solving for sightlines in crowded docks, fitting more cargo in a legal box, or making sure a driver could see every inch of a narrow alley. The result was often a cab that looked out of place, but every angle and window made work faster and safer. Second, torque and flotation. In the Sahara or a muddy Czech logging road, raw horsepower was useless if a truck could not keep its wheels turning or stay on top of soft ground. That is why so many designs prioritized massive, low-pressure tires, engines tuned for grunt over speed, and transmissions with more gears than a locomotive. These were not just heavy haulers, they were machines built to crawl, float, and claw their way through places where roads barely existed. Third, chassis contact and adaptability. Whether it was a backbone tube running the length of a frame, swinging axles that let each wheel find its own path, or quick-release couplings for trailers, the best solutions kept the truck connected to the ground and ready for whatever came next. This meant fewer breakdowns, faster repairs, and the ability to keep moving when conditions changed without warning. Taken together, these lessons reveal a simple truth. When engineers let the job dictate the shape, the result might look odd, but it works. The legacy of these trucks is not just in their silhouettes, it is in the way they solved problems, turning constraint into ingenuity. That is a lesson worth remembering every time a new machine rolls off the line looking a little different from the rest. Today's logistics still rely on vehicles shaped more by purpose than by convention. As automation, urban congestion, and global supply chains push design boundaries, the lesson endures. True innovation often looks strange before it becomes standard. The oddest solutions may be tomorrow's backbone. Uncovering the logic behind these misunderstood machines reminds us that engineering progress favors the bold. For more overlooked stories of practical genius, subscribe and join the search for what really drives change.